Hey everyone, welcome to The Explainer. You're tuning in to the Foundry by Forge College. You know that feeling, right? That absolute cold sweat right before you change a crucial line of code, just terrified you're going to break a perfectly functioning project? Well, you can go ahead and take a deep breath today, because we are going to master git branching. It's essentially a developer's superpower. It lets you create these parallel timelines where you can say full test code, experiment, and honestly, even break things entirely without ever destroying your main timeline. It is literally one of the most liberating tools you'll ever learn. So let's just get right into it. This explainer fits right into our broader module on Introduction to Version Control with Git, which is part of our Solana Development Tools track. Now, if you remember, this builds directly on our previous lesson. We covered commit history and local workflows, right? We learned how each commit acts as this unchangeable snapshot in time. Well, now that you know how to lock in that history, it's time to learn how to safely branch off from it. We're moving from just saving our work to actively managing parallel streams of thought. Okay, let's take a quick look at the architectural blueprint for today. We've got 1, the power of branching, 2, visualizing movable pointers, 3, setting up your repo, 4, creating parallel features, 5, reading the commit graph, and finally, 6, wrapping up the blueprint. Let's dive right in. Starting off with sections 1 and 2, the power of branching and visualizing movable pointers. So think about a traditional linear timeline for a second. If you and a teammate are working on the exact same file, someone's work is inevitably going to overwrite the others. It's a mess. So what exactly is a branch under the hood? Well, by definition, it's simply a named movable pointer to a specific commit in your commit graph history. Imagine you could hit a button and spin off a complete alternate universe of your project. In this alternate universe, you can try out some crazy new idea, make terrible mistakes, completely mess the whole shebang up, and the best part? No way does it destroy your main universe. That is the absolute magic of a Git branch. It gives you the safe, isolated context for your wildest experiments. And this brilliantly illustrates the core concept you really need to internalize. The quote goes, "Treat branches as contexts, pointers plus working tree snapshots." When you switch between branches in Git, you aren't just moving a little digital label or a sticky note around. You are commanding Git to completely swap out your current working directory to match an entirely different reality. Your files, your folders, all of it will instantly physically change on your hard drive to match the exact state of that specific alternate universe. Actually, scratch that. It's quite literally like stepping through a portal. All right, let's move on to step 3, setting up your repo. Okay, so I highly encourage you to create a disposable testing environment so you can safely follow along with this part. We want a throwaway space where you can run commands, see the terminal outputs, and frankly make a bunch of mistakes without any anxiety about ruining a real project. So here are your starting baseline steps. First, create an empty directory and run git init in your terminal to initialize a fresh repo. Second, create a simple file. Just a basic readme.md is totally fine. And third, add the file and run git commit-m core initial commit. Boom. By doing this, you've just locked in your main timeline. This single commit baseline is our stable anchor point. Every wild feature experiment we run today is going to safely diverge right from this exact foundational moment in history. Which brings us to step 4, creating parallel features. Now that we have our stable main timeline anchored, we're going to actively diverge from it and spin up those alternate universes I was talking about. So follow these exact commands. First, run git checkout-b feature/a and commit a new text file there. That -b flag, that's basically your portal gun. It creates the branch and immediately switches you into it. Now, step 2, this is absolutely critical. Switch back to your anchor point by running git checkout main. If you forget this step, your second feature is going to incorrectly inherit the history of your first feature, instead of acting like a clean parallel universe. We definitely don't want that. So, once you're safely back on your main timeline, step 3 is to run git checkout-b feature/b and commit a totally different text file there. Think about the comparison we've just created. In one completely isolated ecosystem, we have branch feature/a containing its specific files. Then, in a totally separate reality, branch feature/b is doing its own thing, completely unaware that feature/a even exists. By the way, if you're taking other Web3 learning programs or courses with Forge College, keeping features strictly isolated like this is absolutely crucial. When you're doing complex smart contract or DOP development, you absolutely do not want highly experimental code bleeding over into your stable, production-ready application. Isolation is security, for sure. Okay, let's head into section 5, reading the commit graph. We've talked a big game about creating alternate universes, right? But how do we actually prove they exist?
Well, Git provides some really powerful built-in terminal commands for this. If you run git branch-all, you'll see a simple list of your branches, with a helpful little asterisk indicating the exact timeline you currently inhabit. But the real star of the show here is git log-graph-all. If you run that, Git literally draws a visual commit graph right there in your text terminal. You'll see ASCII lines showing your feature commits graphically diverging and splitting off from that shared ancestor node we created at the very start. It's incredibly satisfying to see, I promise. And of course, always rely on Git status to make sure your working directory is clean before you try jumping through any portals.
Now, of course, time travel has its risks, right? Let's look at some common timeline anomalies you might run into. If you look at your files and see both of your new feature files on the exact same branch, whoops, you probably forgot to check out main first. If your visual graph shows a straight linear descent instead of parallel tracks, well, you accidentally branched from your first feature instead of the main anchor point. And if Git flat out blocks you from switching branches and throws an error, it just means you have messy, uncommitted files lying around that need to be stashed or committed first. But hey, don't panic if any of this happens. Honestly, messing up a disposable repo is half the fun of learning. Just delete the folder, run git init on a new one, and try the commands again. No big deal.
And that brings us to section 6, wrapping up the blueprint.
Let's do a quick final review of the structural engineering we've actually accomplished today. We successfully moved from a conceptual theory to a tangible, reproducible terminal script that safely manipulates Git's history and allows for dynamic parallel development. So the crucial takeaways are really simple. Never forget that a branch isn't some heavy copy of your project. It's just a lightweight, movable pointer to a specific commit. Always make sure to actively branch from your desired common ancestor, which is usually the main branch, just to ensure your new features start from a clean slate. Keep your main timeline stable and pure by forcing all your chaotic experiments onto these isolated feature branches. And remember your essential terminal commands. Use checkout-b or the more modern switch-c to diverge safely and instantly get to work in your new context. So, I'm going to leave you with this final, kind of provocative thought. You've successfully split the timeline. You know exactly how to build incredible things in completely isolated parallel universes. But eventually, a project has to ship, right? So how do we bring these parallel universes back together, uniting the code into our main project without causing a massive temporal anomaly or, losing our data? Well, that is exactly what we're going to tackle in our next explainer on merging and conflict resolution. To continue your journey, practice these tools, and dive deeper into this subject and other Web3-related topics, make sure to visit forge.college. Thanks so much for focusing in with me today, and I will see you in the next explainer.